Welcome to General Structures 2 and Lateral Forces, lesson number 1 quiz, question number 5. And it says, select the incorrect statement about flexural members. I'm just going to go down the list and I will try to explain why I would not or would choose this answer. Alright, let's start with letter A. Shear stress is often critical for short, heavily loaded spans, and I agree with that, so that is the wrong answer. And if you're interested, typically, I guess I'm here to explain. So if you have a long span, what moment you're looking for is if you have some, you can just look at it as simple as this. Tell you what, open up your steelbook if you have one and look at those equations. And I don't have my steelbook with me at the moment, and I'm not going to get up and go get it. But I do know what this moment is for a simple span, point load right in the middle. Moment equals PL over 4. So you can see for a longer span, you're going to have a bigger moment. So that matters quite a bit. And just knowing what it's a little bit difficult to know this. You're going to have to go through all your equations and compare shear to moment and see what works. But for long beams, moment will control or deflection. For short beams, shear has a chance at controlling, and typically moment won't be an issue. If you have a beam that just looks like that, where this is a foot, 1 foot, and you have a decent sized beam, I'm not going to worry about deflection or moment at all. I will just look at shear. So A is a correct answer, and therefore it is not the one we want. Okay, moving on to B. The two most important determinants of flexural stiffness are the depth of a member and its material. Well, I know that if you go in your steelbook, you know that deflection, and when I'm saying deflection for a simple span, I mean this right here, max deflection at the center, which this should be at the center, but I drew it poorly. So that's deflection max. Is at the center of a simply supported beam that's uniformly distributed load. And a terrible, terrible picture. My sketch there was absolutely pitiful. But I was trying to get around. Max of a uniform distributed load is 5WL to the 4th over 384 EI. And you'll see that other deflection equations will vary from this, but there's typically things that they will always have are this E and I, and it will be L to the 4th typically. But the constants will change and things will change up, but you will typically just have E and I. So the E is has to do with the material, and I has to do with how much is away from the shape, I guess. So the two most important are the depth of a member, and I has heavily BH cubed over 12. H is the depth. So look, you're taking whatever depth and you're you're taking it to the exponent of 3, meaning that's if you have a big depth, you're gonna have a huge I. Now if you have a big width, and you will have very little I as compared to the same amount of concrete, and you put it this way. And that should make sense to you, because you can go look in Steelbook and you can look at your S, or not S, let's keep it IXX versus IYY, and let's say this, let's turn it into steel shapes and just a typical I-beam. And you can look at it, the I-beam, this is the same I-beam, it's just flipped. This is going to be your IXX. This is X, that's why it's called IXX. Ixx will be higher than Iyy. This is your YY axis. So, and that should make sense. You have more area away from the axis, from the neutral axis, and therefore you're going to have a larger I. Because I equals 4 square type sections. And if you could break these into squares, or not squares, but rectangular sections. You can, since you can break all those into rectangular sections, plus AD squared. Alright, and that means that you're taking, as you can see, the AD squared, once again you're taking D squared. So this is the D, it's the center line, it's the area of this flange, times the D is the distance from the center line, not the center line, but the neutral axis, to the centroid of that area. So you can see that if you get a lot of AD squared, that's going to shoot up. That's going to be a very, very large amount of I. And that's how you get your big I's, is that AD squared portion of it. And if you go in here, you'll see that that flange, base times height, is next to nothing. But once you get into AD squared, A squared makes that flange just extremely large. And you do the BH cubed over 12. And the BH cubed over 12 is going to be larger for this web than it is for the web's AD squared, because D equals 0. Since the centroid of that web is at the neutral axis, D equals 0, so you just have BH cubed. But you'll see the BH cubed of this web is still pretty darn low compared to the AD squared of those flanges. And work it out. Probably a good thing to go through is go open up your steelbook and just start computing some of those already computed numbers in there for I's, and if you're interested in doing that, please do so. But that's a correct answer, and that's a no. I is your E is your modulus of elasticity, and that has to do with your I don't want to say safety prop, but I meant to be material stiffness. So B is the incorrect answer. I'm sorry. B is a correct answer, and therefore it's not the answer we're looking for. I'm sorry, this isn't the answer you're looking for. C, the further away a member's material is from the neutral axis, the more efficiently it can resist bending. Yes, I is good for bending. We just kind of said that. I'm not going to beat a dead horse. That is a correct statement, and therefore it is not an incorrect statement, and not the droids we're looking for. D, stiffness and strength are structural terms that may be used interchangeably. And I'm guessing this is going to be our answer. But stiffness and strength can be used interchangeably. And I would say no, because remember what stiffness is more based on this deflection. How much is it going to deflect? And that's based right here. And strength is more of your, what is your material strength, your Fy, or your stress and bending. And the fact is, they are similar, but I wouldn't say they can be used interchangeably by any means. So D is going to be your answer for question number 5.